So today our webinar is Fit to Burst, Frozen Pipes and Water Damage Claims. Next slide, please. Our presenter is Dino Mattei, who is a senior consulting forensic engineer here at Origin and Cause. He has over 30 years of industry and academic experience. He's completed over 2,000 forensic investigations. Some of his mechanical and materials engineering specialties include failure analysis, product liability, plumbing systems and components failures, oil spills, corrosion, metallurgical and fractography investigations, insurance fraud investigations, and personal injuries. So without further ado, I'm going to hand things off to Dino. Dino, please take it away.
Hello, everyone, and welcome to our webinar. It's good timing because it's the onset of cold season, so it's just a good topic to discuss before the cold season goes in full speed. Our company was involved throughout the years in numerous claims associated with freezing. Although sometimes it's a pretty straightforward investigation, oftentimes it's not. So we take all the precautions and we are investigating all the aspects to make sure that we discover what caused that particular flood, because it's possible that it's a failure of the furnace and the furnace stopped working. Obviously, there's no heat in the house. Let's start to talk about Let's present a few interesting facts about freezing water. The freezing point of water is the temperature at which water changes phase from liquid to solid, and it's 0 degrees Celsius or 32 degrees Fahrenheit. Upon freezing, the volume of water increases by as much as 9%. This is a lot, and this would explain why the pipes can burst. And another interesting factor is that upon freezing, the pressure of a pipe filled with water can go as high as 19,000 psi. This is huge. And it also must be mentioned that it's not always the mechanical expansion of the ice that causes a pipe to burst, but the pressure buildup downstream. So the ice plug forms in a certain spot, and downstream from that ice plug, the pressure buildup. It's like in a syringe piston, and the pressure has nowhere to go, so it will eventually let go in the weakest point of the plumbing system, which could be a solder joint, could be an elbow, could be a solenoid valve from an appliance, or again, it can be the pipe itself. A few other interesting facts about freezing. What can freeze? Anything that contains water can freeze, and here we are not talking about salt water, it's just regular water. It also must be noted that running water does not freeze, and warm water freezes quicker than the cold water, and this is called Mpeba effect. This is a guy from Tanzania who discovered in 1962, when he was preparing ice cream, that the bowl with the warm ice cream froze quicker than the cold one. On a regular 4-bedroom home, which is kept at 22 degrees Celsius, it takes approximately 12 hours to go to freezing temperature. Of course, this depends on how good the house is isolated, the windows and the doors. One must note that the temperature in a house is not uniform throughout. We set up the temperature through the thermostat, and the thermostat does not measure the temperature in further away corners of the house. So you can have 22 degrees Celsius in the hallway, but in one corner of the basement, the temperature could be lower. And interesting thing about freezing is not always detrimental. It's used to create a seal to repair water pipes without draining the system. So there are special devices that can cause localized freezing, and the ice block prevents the water to flow so the repairs can be performed. There are a lot of reasons that can cause freezing in a house. Obviously, doors or windows left open or ajar. The furnace that can be started with oxygen. It's ice or snow that builds up on the air intake, so the furnace will stop working. Oftentimes, the thermostat is turned off, especially if people are away for an extended period of time, or the thermostat is set too low, or the thermostat batteries are depleted. One relative common occurrence, and there is no coverage for the damage, is when the furnace malfunctions. It actually happened to me this Monday. The low pressure switch died. So the first day of the winter here in Ontario with minus temperatures, my furnace malfunctioned. Luckily, I was at home and I managed to fix it. There are certain buildings where pipe is running in the attic space, and over time the insulation can shift, or oftentimes the insulation is completely missing. We have seen floods in cottages which were not properly winterized. It's recommended to drain the pipes before the winter season comes in. We have seen instances where outdoor bathtubs froze. Another reason for freezing is power outage, or the garage door left open and cold air comes inside the house. Another instance is when a plumbing component failed, and as the result, the furnace is flooded. So in this instances, the failure start with a plumbing component that led to furnace flooding and subsequent freezing. And an interesting thing is, if the water at the tap trickle, or if there's no water coming through, it means the pipes are frozen somewhere. And the ice block can form in various places, and it's quite difficult to detect. You as adjusters and us engineers, we are dealing with flooded homes due to freezing, and there are certain things that we need to be careful when we start the investigation. We need to find out whether the residence was occupied or not occupied. And if the owners were away for how long, what was the thermostat temperature setting? Was the water turned off? How often the house was checked? Who discovered the flood? What measures were taken? And how many leak locations were found? It's also important for our investigation to compare utility bills from this time of the year with the similar time from a previous year. So if the water bill is rather large, one can say that water inside that home runs for several days, not hours. It's very important to have the furnace inspected at the onset of cold season. So have a gas technician, clean the furnace, make sure that it fires properly, the filter is changed, and everything is in order. As I mentioned earlier, freezing can occur because ice buildup or snow blocking the furnace air intake. So at the onset of the claim, it's crucial to look at the air intake outside the building and see if it was blocked or not. And in commercial settings, things to ask and to look for are depending on each case. Oftentimes, we are not retained when the claim was discovered, but after several days. And during this time, the restoration company took over and they started the remediation work. And during this work, the condition of the site is altered. And it's very important for us to see not the extent of the damage, but the leak locations. Oftentimes, restoration companies are taking lots and lots of pictures of the extent of the damage, but they don't take any picture of what caused the damage. And this is very important for us. If you attend the site soon enough, document the thermostat and the furnace. Call a forensic engineer as soon as possible. Again, ask for utility bills. And floods occur due to freezing when the ice is thawing, but the ice formed in the piping system days or even weeks before. So it's really relevant to check the weather conditions history in the area before the day of the loss, a week or 2 weeks before, or even longer. I chose 4 different websites. My favorites are the last 2 ones. The first 2 ones provide data only from locations where there's a weather station. The other 2, they provide data from areas where there is no weather station, which is very helpful. Also, when you attend the site, do not allow removal or alteration of the thermostat or the furnace until they are inspected by a forensic engineer in as-is condition. And do not allow removal, disposal of the pipe sections or components that leaked water. We ran into situations when the evidence was discarded by the restoration company, and that made our investigation more difficult. It's definitely freezing when you reach a house where there are multiple leak locations. Those 5 photographs here are showing evidence from the same house. The house was frozen solid. You can see on the upper left image numerous pipe sections that failed. In the middle upper picture, there is a sink. On the right side is a toilet tank. On the lower left side, there is a water filtration system that was installed in the kitchen. And in the 5th image, there are some pipes that were installed in the bathroom. Also, it's definitely freezing when the walls are covered in ice. I don't know if it's clear enough in this picture, but the bricks, this is an interior wall, by the way, are covered in a thin layer of ice. In this case, again, the house was solid frozen. And I would like to present a few case studies which were interesting, and they were all related to freezing. In case study number 1, we are talking about an instant heater, and as you can see, 2 of the coils exhibit ruptures. The problem with this instant heater was that it was installed below an exhaust pipe, and you can see here there was no insulation between the pipe and the wall, and cold air entered into the room, and because cold air is heavier than warm air, it landed on the instant heater, causing it to freeze. So in this particular case, the problem was associated with an installation issue. As I mentioned earlier, there are a lot of instances where pipes are running in attic space, and especially in buildings which are equipped with sprinkler systems. The most common pipes for sprinkler systems are these orange ones called CPVC, and if they are run in a non-insulated place, they can freeze. They have a typical appearance when they freeze, and they're easy to detect. But in order for a complete investigation, we would need to go to the site and document the condition. In the top picture on the left side, you see the pipes are resting on a piece of wood, and the insulation shifted. On the larger image on the right side, you can see through the soffit outside the building. So there was cold air and cold current flow, which allowed the pipes to freeze. As I mentioned earlier, the flood can occur away from the ice plug. So this would explain why some of the burst pipes or components fell in the middle of the house, not on the outside wall. And in these three images, I'm showing three solenoid valves associated with refrigerators, which failed due to freezing. Even the house was warmed because the ice plug formed somewhere near the outside window. We take those valves and we look under the microscope and eliminate a manufacturing process or chemical contamination, and there are specific features which tells us they failed because of freezing. Hose bibs. We all have those in our backyard, and they are designed to have the shut-off valve closing inside the house, not on the outside wall. So this is designed to prevent freezing from occurring. However, if the hose bib is not installed properly, it's not sloped correctly, even the valve inside is closed, water cannot be evacuated and remains stagnant, and during cold season, it can freeze. There are a lot of cases associated with those hose bibs. Braided lines usually failed as the result of corrosion due to exposure to chemical stored under the sink. Household cleaning compounds contain ammonia, contain chlorine, which are detrimental to brass and steel. Those failures are typical, and this one was unusual because there's no significant corrosion on the braids that failed. So by looking under the microscope, I determined that they failed due to ductile overload, and by checking the weather conditions and the fact that the home was not occupied, I reached out the conclusion that it was because of freezing. As you can see, the nut was expelled from the hose. These Victolic couplings are from a commercial building, and they are designed to withstand up to 4,000 psi of pressure. So they don't fail easily. But if you look at the flange at the lower side on the image, you can see that the cast iron coupling is completely fractured. There is no manufacturing deficiency, there is no installation issue. And again, by looking at the data and analyzing all the facts, we concluded that it was, in fact, due to freezing. And later on, we found out that this particular section ran into a side of the building that was not heated. I mentioned earlier furnace failures. And in this particular case, although there is no coverage because it's freezing, it's not the owner's fault. It's either a problem in the furnace or it was a repairman who did a poor job. In this particular instance, the owners asked their repairman to fix their furnace, and in the process, he broke that piece of plastic which is shown in the right side image. And because of that, the furnace stopped working and the entire house froze. We don't have only water pipes that freeze, we have oil installation that can freeze. And in this image, you are looking at an inline filter at the bottom of an oil storage tank. And what you see below the red lid, it's actually a chunk of ice. The filter itself, it's on the lower side of the image. This image was very precious for the investigation because a few days later, the weather condition changed and the ice plug melted, and it would have been basically difficult to say exactly what happened. So in oil installations, you have water that's accumulated due to condensation. And because water is heavier than oil, it always stays at the bottom of the tank. And when the oil is running through the furnace, the first things to draw out from the tank is water, and it accumulates inside the oil filter. The manufacturer requirements are that to change the filter at the onset of cold season, and when there is water accumulated, evacuate it. This particular instance deals with so-called sharp bite connections, which most of you are familiar. These are connections that were on the market for 10, 12 years now. They're easy to install because there is no need to any tools, you just connect them. And in 15 years of working with Origin and cars, I did not see any of them failed as a result of manufacturing deficiency. Now the patent expired, so a lot of other firms developed alligator connectors, for example, which are not as good as the original sharp bite ones. So this was severely damaged because of freezing. There is no manufacturing defect. There was no overpressure in the system. It was just freezing. I'm sure a lot of you dealt with toilet connectors failures, and they usually fail by complete circumferential fracture of the plastic coupling, which is attached to the underside of the toilet. And their failure is usually by creep, which occurs over time because of manufacturing deficiencies and constant stress. In this particular case, I looked under the microscope at the fracture surface, and the fracture surface showed characteristics which are not associated with creep and more likely are associated with ductile overload. So again, after some analysis, I concluded that this toilet connector did not fail as the result of manufacturing problem, but it failed as the result of freezing. And upon my conclusion, the adjuster confirmed with me that the home was not occupied for extensive period of time and the water was not turned off. Case study 11, it's a construction project at the university. And as you can see in the lower image, there is a lab and there are numerous faucets. And the management decided to replace the windows when it was the coldest time of the year. So during this time, there was no insulation. So there were proper conditions for freezing to occur in the lab. And the installer of the windows said, well, it's a manufacturing problem, it's not our problem. And it was this key which shows the typical opening associated with freezing. So again, we examined it under the microscope. We determined that there was absolutely no manufacturing deficiency with it, and it failed as the result of freezing. It must be mentioned that when you're looking at under a powerful microscope, there are features which help us to determine why it failed. If the part is present, it cannot hide from us why it failed. And under the circumstances in this particular case, there was no doubt that the incident occurred as a result of freezing. This is a section of a sprinkler system that was installed in an underground parking lot in Toronto. And as you can see, it froze and you can actually see the big chunk of ice coming out from the opening. The problem was here a power outage, and the second problem was the building did not have a backup system. So it was very cold for extensive period of time, and this allowed the pipes to freeze. there are wet sprinkler systems and dry sprinkler systems. Dry sprinkler systems are exactly what the name said, dry. They have no water inside the pipes because the pipes run in unheated spaces. So they're designed for special instances where the pipes run into isolated spaces and it's prone to freezing. However, like in the case of oil tanks, there is condensation and water can form inside the pipes. Plus, the system is required to be checked once a year, so there is water that's flushed through it. They have to be sloped in a certain way, and before the onset of the cold season, they need to be drained. So the stagnant water needs to be evacuated. If the system is not drained, the water will freeze, and it causes, in this particular case, a split like visible in this image. So the culprit in this instance was the installer who did not slope the pipes correctly, and it was also the inspection or the maintenance crew who failed to drain the pipes. And I was told by a client on a different file where I said, well, here's the inspection checklist, and it says that they drained the pipes. And she said, yes, they checked it, but that doesn't mean the pipe was actually drained. They just put the check mark and the water was still present. Otherwise, the system would have not freeze. This is a case involving a warehouse for frozen food, actually. And it's a small building, and you can see those window-looking features, the gray ones, which are actually dampers. And the sprinkler system inside the building runs above the freezers, and there's no insulation there. So these dampers are designed to close or open when the temperature changes. And in this particular case, it was a malfunction at the controllers. So when freezing condition occurred outside, the dampers failed to close, so cold air entered into the building and caused damage to the sprinkler system. Cold air spots. That's the most dangerous situation for a pipe filled with water. In this particular instance, you are looking from inside towards the aluminum panels of a recent building. And you can see in the first picture up here that the gap between the panels is covered with duct tape. There's no insulation everywhere, so there are areas where there is no insulation. And if you look on the lower picture, you can see here where there is more light, you can actually see outside. And when I went outside the building and I looked at the panels, you can see that the rubber insulation was not properly attached. So there were numerous and favorable conditions for freezing to occur, and this is exactly what happened. There were several pipes that froze and burst. And this is an obvious situation, and we were blown away when we saw that the thermostat had no battery. So there is no way to communicate with the furnace and tell the furnace to light up. I mentioned earlier about the toilet connector that failed. Here we are looking at a bidet, and you can see that the nut separated from the insert up here. And the house was under renovation, and there was nobody living there. And when I looked under the microscope again, I saw features which are characteristic to ductile overload and not creep or any other degradation mechanism. Before we end this presentation, I just want to talk about prevention tips. How to prevent freezing. Best prevention is make sure that the heat source never stops. So if you're going away, don't turn the furnace off. Allow warm air to circulate throughout the entire house. There are people that have finished basements where, to save energy, they are closing the vents. So this causes not only a potential condition for freezing, but it also prevents the house to breathe. So these vents are not designed for nothing. They have a purpose. So if you want to save some money during winter time or during summertime when you run the AC unit, just close them a little, but don't close them completely. There are areas where the drafts enter, and they need to be identified and blocked. As I mentioned, insulation can shift. You can have the door that allows water to air, to enter. Make sure that pipe runs are insulated. There are already made available pipe sleeves. You can buy at any hardware store and insulate the pipe. I also pay attention to the perimeters of the house because oftentimes the situation changes and there are cold air spots or areas where cold air can enter. And I also watch for cold spots under plumbing fixtures like sinks. I cannot emphasize enough how important it is not to turn heat off during the cold weather. And a tip that not many people are aware of is don't leave the door of your dryer open. Your dryer communicates with outside. So if you leave the door open, cold air can enter through the dryer into your basement. Before the onset of cold season, disconnect the outside water supplies, unhook hoses, and shut off the water from inside. Make sure the lawn irrigation and recreational water sources are off and dry. And because running water does not freeze, if it's very cold outside, let the water trickle. Even the tiniest trickle will prevent freezing. A few years ago, there were minus 44 degrees Celsius in Toronto. And I was about to go on vacation. And I went to do the dishes and I noticed there's no water. Oh, I knew exactly what happened. So I took a hairdryer and hit the pipe. So eventually the water came back, and luckily I did not have any event. But if this would have happened while I was away, who knows what would have been the end result. As I mentioned, have a hairdryer handy, and it can help thaw out frozen pipes. Again, it's hard to get the exact location of the ice plug. So run it through the entire leg of the pipe, which is exposed, and you have access to it, and that can help thaw the pipes. Before going away on vacation, even during summertime, it's advisable to turn off the water at the main and drain the pipes by opening the very top and the very low faucet. So in case there are areas where stagnant water can accumulate and freeze during winter time, if you have the faucets open, the pressure will be eliminated through these openings. And moreover, when you come back and turn back on the water, if you have those tabs open, that will prevent water hammering from occurring. So I suggest leave the top and low faucets open. Make sure the thermostat is working. Make sure that the batteries are changed before the onset of cold season. Batteries nowadays can last longer. However, usually they are drained during the cold season. So before the onset of cold season, it's recommended to replace the thermostat batteries. In my opinion, when you're away, so the suggestion is not to leave the temperature below 12 degrees Celsius. Because if you have 12 degrees Celsius in hallway, you might have 0 in the basement, and you are looking for trouble. Make sure someone is checking the house, including the basement. Oftentimes, people who are checking our homes are just picking up the mail, look on the first floor, there's no problem, but it don't go in the basement, and the problem could be already there. Again, make sure the furnace is working and it's warm throughout the entire house. This concludes my webinar. I hope you enjoyed it. I hope you learned something from it. And once again, I thank you for joining us today. And I'll be more than happy to answer any questions if I can.
All right, thanks very much, Dino. Yeah, we do have some questions already. So why don't we, we'll go through those, and then, yeah, let's give everyone else time to kind of digest some information. And if anyone else has questions, please submit them now. So let's start with this one here. When you have a dry fire suppression system on the exterior of a building, should it be required to be drained prior to the cold season? And should it be mandatory to have bleed valves or drainage valves?
There is an NFPA requirement about the dry sprinkler systems, which says that you have to evacuate the stagnant water regardless.
And is that like at a certain time of year, or is that just?
Well, usually it's recommended to be done before the onset of the cold season, right? If you have stagnant water during summertime, that's not an issue, right? The problem starts during winter time.
Okay, great.
And with the sprinkler systems, oftentimes we reach the site after the remediation works started because they didn't want to keep the building under fire code, fire alarm, sorry, fire watch, sorry. So they want to restore the system as quick as possible. And by the time we attend the site, the slope is changed and the water is gone. So I'm taking this opportunity to remind everyone to call us as soon as possible to attend the site, because if we're going there later, we might have difficulties in determining exactly what happened.
Okay, fantastic. Okay. So you say do not allow for the removal or disposal of pipe sections that leaked. Does this mean do not remove from the property, or can it be removed or can it be removed or repaired to stop the leak once water has been restored?
Well, we don't have control on that, and ideally would be to preserve the site as is, so we can see exactly where the water was coming through. So if we receive the pipe sections like I showed you in one of the previous slides, they were lying on the floor. We did not know where they were coming from. So it's important for the investigation, if possible, to call us before the site is altered.
Okay. So yeah, leave it as is, and I guess at the very least preserve the pipe sections. Definitely don't throw them out.
Oh, definitely no. Yeah.
Yes. I believe you covered this. Ideal temperature setting in winter went away. I think it was 12 degrees.
That depends on how good your house is insulated. And in my house, I keep it at 12 if I'm away.
So what would be what's the 12 would be the coldest spot? Is that what you're kind of basing that on?
No, I really don't know how I choose that temperature, to be honest with you.
Okay. All right. How does insulation in the attic shift?
It can settle because it has a certain thickness, and over time it just settles, and sometimes you have air movement in the attic space because you have to let the building breathe. And depending on the weather conditions, that air can shift insulation.
Okay. Do you recommend changing supply lines on toilets and sinks? Maybe you might need more clarification on that one, possibly.
There is one manufacturer which put a label on one of the braided hoses, which says replace every 5 years. There is another manufacturer who produces water supply line for washing machines,
Mm-hmm.
and it says replace every 5 years. I installed mine 8 years ago, but I'm trying not to keep any chemicals under the sink. Until I start working in this industry, I put all the chemicals under the sink, regardless. Where else do I put them? But after seeing so many failures, and the majority of them occurred because of corrosion, I removed all the chemicals. And again, if you're cleaning your toilet, you don't have to go aggressive. Even a mild solution will clean the dirt. You don't have to use all those chemicals because they create vapors and they will affect the pipes. And with toilet connectors, the industry recently started to change the material and change the design. As you probably know, the old ones are white. Now they are bulkier and they're made of a different material, which is more resistant. And because of the number of claims, some of the manufacturers, and I will not mention names here, they actually stopped making braided hoses or toilet connectors because it was too much for them. And I mentioned that one manufacturer puts a label on them suggesting to replace it every 5 years. But how many people are keeping those labels, right? They are removed for cosmetic purposes. So we can identify the manufacturer, but we don't know what were the instructions when that particular hose was installed. It's very rare that those labels are kept attached to the braids.
Okay, yeah, that was great. Is it common for freezing to occur in fridge lines?
Sorry, where?
Refrigerators, yeah, I guess if you had an ice maker or a water filtration system or something.
Yes, what is the question?
Is it common for freezing to occur?
Yes.
On
one slide, I had 3 examples of solenoid valves that were associated with some kitchen appliances that failed as the result of freezing.
Oh, okay.
And oftentimes I'm asked, how can it freeze there when it was warm? And I'm saying, it did not freeze there. It froze somewhere else. It's the pressure buildup. It's not only the mechanical expansion of the ice. Because for some people, it's hard to understand how come I have 20 degrees in the house and my fridge froze. It's not your fridge that froze, it's a pipe that froze somewhere else.
Okay, fantastic. Any recommendations for preparing for a vacation when living in a high-rise condo where they have water heat and an old analog style thermostat?
Well, first you depend on the neighbors above, right? So if they don't take care of their home, your home is flooded. But if you're asking only about your specific unit, I would leave the thermostat on. So in an apartment building, especially if it's not a corner unit, your unit might be heated from the unit besides. So it's not that cold. But I would leave the thermostat on.
Okay. Let's see. Oh, you know what? I was actually going to ask this question for myself. Have you seen any issues with from Google Nest smart thermostats, or let's say an Ecobee or any smart thermostat?
They are relatively new, and I was involved in one failure only, and that failure was because of a power outage.
Okay. All right. Let's see. Here we go. Did I hear correct that a copper pipe may be subjected to over 19,000 psi while frozen?
That's from an article about freezing. It's a very good article. It's easy to read, and it explains various experiments that were done throughout the years with freezing. And they said the pressure could be higher, but there are no pressure gauges that can take more than 20,000 psi.
All right, great. It's a lot of pressure.
Yes, it is.
If the home did not have heat working for whatever reason should, sorry, give me a second here. If the home did not have heat working for whatever reason, should have frozen pipe occur. Where is the likelihood? Sure, I'm just gonna need, maybe clarification on this question here. When operating a dewatering system with an electric pump, that pumps water through a pipeline, there is a concern for freezing should the power be interrupted for a period of time. Would adding salt to the pump pit and a salt additive to the discharge line prevent freezing?
Well, obviously salt water freezes at higher temperatures, but I would not add because salt is corrosive and it will damage the pump. Plus, it will contaminate your pipes.
Okay. Let's see.
We did not see any incidents with, if you're talking about sump pumps that caused freezing. As I mentioned earlier, running water does not freeze. So most sump pumps work at several interval of times. It's not they are idling for an extended period of time.
Okay.
And oftentimes they fail for other reasons, not because of freezing.
Okay, let's see. A lot of questions. I'm just trying to find ones that are new. So actually, this relates to an earlier question. So do natural products cause corrosion the same as other products if kept under the sink?
Natural product?
Mm-hmm.
That's a very good question. What natural products, for example? I cannot think of any, to be honest.
Okay. So yeah, for the person who asked, if you can think of a specific product, maybe we can get back to you via email on that one. Is there a benefit to insulating PEX piping with sleeves like you would with copper piping?
PEX is a material that's more forgiving to freezing than copper, so it can expand more than copper. So usually PEX pipes don't freeze, but if you have concerns that the pipe is running near a cold air spot, it won't hurt to insulate them.
Okay. Do you have any recommendations for how often hot water tanks need to be replaced? Residential hot water tanks, that is.
That depends on the area where you live. There are some areas where there's hard water. There are areas where there is mild water. So if you have hard water, it's very likely that you have a water softener and you have salt in it. So that will accelerate the deterioration of the hot water tank. I've seen instances where the tank failed after 3 years, and I've seen instances where the tank lasted 19. Every manufacturer recommends to check the anode once a year. However, they admit that checking that anode is basically impossible. It's hard to remove it. My suggestion is to have the hot water tank rinsed once a year. When you have your furnace inspected, you can ask the same guy to flush the tank, and all the deposits at the bottom will be eliminated, and this will extend the life of the tank. When I rented the tank, I asked the company, the tank was 8 years old, and I said, it's 8 years old, it's close to its life expectancy. Could you please check the anode? And they said, no. I said, what do you mean, no? He said, well, if there is a leak, we'll give you a new tank. That was the answer. So now I own a tank, so I'm trying to take good care of it. I'm not saying it's proof, but I have control. So once again, it's a good idea to have the tank flashed once a year, and you have to have it done by a specialist because they have to play with the valves, and you don't want to create a water hammer effect. And you can drain the water into the sink in the basement or in a bucket. Every tank is equipped with a discharge valve at the bottom that can be used for flushing the tank.
All right, it's great advice to take on board. Is it common for city sewer pipes to freeze, and who would be responsible for that?
Sorry, what was the question?
Is it common for city sewer pipes to freeze? So let's say
they run below ground and usually don't have freezing temperatures at that depth. I personally did not run into a city pipe that burst, the underground pipe.
Okay. What about something running from a house to the main line, which I think would then be the property owner's pipe, right?
Again, that's underground, and you don't have freezing temperature there.
Can a pipe rupture even if there is space on either end to expand?
I'm not sure I understand by space to expand at both ends. It means that the pipe is open.
Okay, yeah, if the asker of that question wants to clarify, we'll see.
Yeah, I'll be more than happy to answer it. Yeah.
Okay. Let's see. Would spray foam insulation around pipes prevent freezing in a heated portion I'm going to say an unheated portion of the home, such as attic or garage?
That's a very good question. I'm not familiar with the thermal properties of foam insulation. I cannot answer this question. I'm sorry.
Okay. How quickly after a leak occurs is it possible for mold to appear in a heated building?
Again, I'm not a mold specialist. There are specialized companies who are dealing with it. As far as I know, there are various types of molds, and one thrive under certain conditions, and other thrive under different conditions. But if there is a hot water line that bursts, then you will have excessive heat in the home, and mold will likely form faster than when it's a cold water line that burst.
Okay. If a furnace stopped working in the home, where would you likely experience a possible frozen pipe?
In a cold air spot.
Okay. Which I guess would vary from home to home?
Yes, and it's usually one that's closer to an outside wall.
Okay.
It would be under the sink in the kitchen, because most kitchen sinks are towards the outside wall, and the pipe runs there.
Okay. I think we kind of talked about this, but can PEX pipe handle the expansion of frozen water without damage?
As I said, PEX is more forgiving when it comes to freezing, so it can expand and can withstand that expansion. It's more elastic than the copper.
What do you recommend for sump pump discharge lines during the winter? We have them ice up and freeze. We've installed 4-inch drain lines.
All the drain pipes for sump pumps are ABS, as far as I know.
Okay, yeah, let us know if that answers your question. Let's see. I think, let's see. I think that might do it. But if anybody else has any more questions, I'm just going over these again, but we've got about 3 more minutes. All right, we got a long one that just came in. Let's see if I can get to this. In the context of all risk insurance policies, when the homeowner has left for more than 4 consecutive days, as long as the home is being checked by a competent person daily to ensure the heat is being maintained, you would be insured against freezing. As used in your example of 12 degrees for your 12 degrees for your home is not adequate for an old farmhouse kitchen sink, as it may be.
No, as I said, that was my choice, and
Yeah.
I really don't know how I came up with that number. And in the last years, I actually did not turn the heat off or down at all. I mean, it's worth paying a few extra bucks than having an insurance claim.
Mm-hmm. Yes. So
Speaking with homeowners and friends, how often the house is checked varies from insurance company to insurance company.
Yeah.
One is requesting your house to be checked every 48 hours. In my particular case, it says when it's reasonable. I don't know what that reasonable is, but that's what it says in my policy.
Okay, well, there we go. We are at 2 o'clock. Any questions that still come in, we'll get back to you via email. So I think you will be presented with a survey at the end of the webinar, and yeah, if you want to fill that out, or if anything else just comes to mind, we've got Dinu's email up there on the screen. You can email him directly, and I'm just going to repeat for everyone here who's going to ask about completion certificates. We are going to be sending them out. We are still waiting to hear from Saskatchewan and Alberta about accreditation. It is accredited in Manitoba, and it is eligible for accreditation in British Columbia. If you have questions about that, feel free to reach out. Yes, we're going to be sending everything out as soon as possible. Okay, that's it. Thank you, Dinu, and thank you, everybody, for attending. Have a great afternoon.
Thank you, Mark, and thank you guys for attending, and thank you for the questions.
All right, have a great day. Bye.